Mr. Minnick helping my Java students with Boolean Algebra Worksheet number 1. This is a very tough topic. It's good to have the Boolean algebra identities available nearby as you work on simplifying these expressions. Each of these expressions could be an if statement, control expression in any computer language really. So really what we would have is an if keyword here, then a big fat set of parentheses, then a curly brace, and it would say something like system out print hello world, and it would come down to whether hello world displays or not, whether this is true or whether all of this in the parentheses is false. That's the real goal here, but on this worksheet I'm just showing you how you can use Boolean algebra identities to simplify a complicated expression and perhaps write cleaner, more refined code or understand somebody else's unrefined, wordy code. Here goes. This first expression that's given on this worksheet, we have a not and it's spread out over this complete set of parentheses, so with an and in the middle. So anytime you have a not with something anded with something, you can distribute the not and rewrite it 2 times. And you can break it down over the 2 little mini expressions. So by rewriting it like that and showing your work, that would be wrong. You can't do that. You have to put the not in front of this whole relational expression with the greater than. And this not really applies to this whole expression. It's kind of like a negative sign. And the not is there, and the not is there, and you now have to change the and to an or. That's the key. This is called De Morgan's Law, and that law says that anytime you have a not in front of a big control expression with an and, you can distribute the not, but you have to change the and to an or. So this expression in red is equivalent to this expression. It doesn't look any simpler, because it isn't really any simpler. But this is always what we're supposed to do next in a problem like this or on the AP exam, wherever you might see this kind of a problem. Okay, the next step. Oh, and I always like to put a little equal symbol to make it clear to the teacher that's reading this that this expression equals this expression. Now we can go further, in my opinion. We can break this, we can get rid of this not here. The not of num greater than 0. Think about it. What's the opposite of greater than 0? If you have a number that's greater than the number 0, that means it's over here in the number line. But it's not 0 itself, because greater than 0 means that's an open circle. Well, what's the opposite of this shaded in area on the number line? Well, the opposite is the number line formed by the negative end filled in and the point 0 filled in. So that's the opposite of open circle. So the opposite of this, in other words, we have to rewrite this as num less than or equal to 0. Sorry about the sloppiness there. Now don't forget about the or, because that's still in the middle of this big expression. And similarly, when we have the not of a less than or equal to, the opposite of less than or equal to is strictly greater than. And we have to rewrite temp and the 0. Now we don't need these parentheses anymore. They've dissolved away. Because of the order of operations, relational operators, less thans and greater thans, always execute before logical operators like and or. So that is the final answer, in my opinion, for this question. It was only 2 steps, and the reason for this step that we're allowed to do this is called De Morgan's Law. Number 2, I see that there's a not in front of a big set of outer parentheses. You got to be very clear on where the parentheses are. Now this not is a little like mini not. It's only tied to this part right here. So let's work from inside the parentheses out, and let's distribute that. It's not distribution actually. Let's just apply that inner not. The opposite of greater than is less than or equal to. So we can rewrite this right half as simply num less than or equal to 0. And you should probably, to be safe, keep one outer set of parentheses around that, and then rewrite this OR, and rewrite the left half. Don't do too much in one step. So I only applied this not in this first step here. And we do have this extra not way out here, and that not still applies to this whole control expression. So this bigger set of parentheses is what the outer not applies to. I really didn't need to rewrite the inner set of parentheses, I realize now, but it was safe. It was just a safe thing to do. Okay, what do I do next? Well, you should realize that this is now a chance to apply De Morgan's law again. This not can be distributed to both the sum less than 5/2 with its little a new set of parentheses. Just like we had added a new set of small parentheses here when we took that not and applied it to this, you have to add a set of parentheses here when you apply this not to the sum less than 5. Okay, we have the OR, but it changes to an AND. It changes to a logical operation of AND because that's what De Morgan's law says to do. And then we rewrite this right half. Oh, but with a not in front of it because we had to distribute this big not to this right half also. Don't try to do too much work at once. I know there are more steps here. You need to now introduce a little mini set of parentheses so that that not applies to all of this. You would not say not of num. That just doesn't make sense. The not, you don't put a not in front of a integer variable. Just don't do that. Okay, I've now eliminated the outer parentheses in this problem here. So we are now reduced to this. And now it's this kind of the same as the last step up here. The not of less than is greater than or equal to. And you rewrite the sum and you rewrite the 5. The AND stays the same now because we're not actually applying De Morgan's law in this step. And this not switches this less than or equal to a strictly greater than symbol. And you rewrite the variable num. And we're done. Sum greater than or equal to 5 and num greater than 0. We applied De Morgan's law going from the first step to the second step. And I repeat, I have a web page full of Boolean algebra identities, including the two versions of De Morgan's law. And right here, for those of you not familiar with my website, if you're looking at this from some other school, there is my website address for this page of handy rules. Number 3, moving a little faster than we needed to move. Now sometimes I like to plug in variables like a and b for these little mini expressions. Let's just try that and see if you like this kind of thing. I'm going to rewrite number 3 here as not a ANDed with a. And just over here my key, I'll just stress that num greater than 0 over here in this problem is equivalent to like the variable a. So it keeps you focused on like the Boolean algebra rather than the numbers and the integer variables. Well, where do I go with this? This isn't really De Morgan's law. Well, actually you could apply De Morgan's law. You could do the not of a ORed with the not of a. So that actually is quite fine. And if you take the not of a, well, now it's time to plug the greater than 0 back in. So you might say the not of parentheses num greater than 0, a little mini set of parentheses, being ORed with the not of num greater than 0. And again, if you're given to doing the problem this way, you would write not. The opposite of greater than is less than or equal to. So you end up reducing your problem to this. Still with an OR, and the right-hand side is exactly the same as the left-hand side. But then you look at that and that seems terribly redundant. Well, either you just have good intuition and logic, and you were born that way, or you refer to my Boolean algebra identities where when you have an a ORed with the same thing, it equals a. You know, it doesn't matter if a is true or false. If a is true, then a true ORed with a true is overall true. If A is false, a false ORed with a false is overall false. In other words, it doesn't matter what number num is actually storing, whether it's a negative number or it's a number greater than 0. It doesn't matter. This really just simplifies to simply A, which on this problem is simply, oh no, it simplifies to not A. So in other words, it simplifies to num less than or equal to 0. Now, important note, you put up with a lot of long-winded explanation here. I am going to make this a wrong answer, and do not put this on your worksheet if this is collected in your class. I'm going to change this. I'm going to use the color blue to remind me of this in the future. But this was the evil idea of some period 1 students in the year 2015. And we're just going to put a greater than sign in there. And then that's going to really throw people, cheaters off. And they're going to have the opposite of what they should have if they look at the final screen of this video. So do not write that on your paper at home. That should have been a num less than or equal to 0. Okay, moving on then to number 4. Here number 4, back to red. Ooh, this is a doozy. Okay, we might have to use a lot of Boolean algebra identities. Working from inside out, I see that this can be rewritten here as less than or equal to 0 by applying this not. So really I'm going to use n instead of num because I'm not good at writing with this mouse. Okay, this not applies to the whole expression right here. So make sure that the red parentheses stay where they are. These parentheses here dissolved away into just num less than or equal to 0. Now let's rewrite everything else, and I'm using a T there instead of the word temp. Rewrite everything else. Don't try to do everything in your head. Even if you're gifted or you just think you're gifted, please show your work and your steps. You'll save errors. Now the next thing that I would do if I were doing this problem, you have to apply De Morgan's law over here on the left-hand side. So this not introduces a new set of mini parentheses right here around the num less than or equal to 0. This or changes to an and. This is by De Morgan's law if a teacher asked you why you went from this step to this step. And now I'm going to distribute that not over there to this half and put temp less than or equal to 0 in its own mini set of parentheses. And now we have another and here and a num greater than 0. But here's the problem. Do we add another set of parentheses or not? No. It is not proper to introduce another new set of parentheses. This is now the equivalent step that we need. Now this not can apply to this less than or equal to 0 and change it to a greater than 0. And that dissolves those parentheses. This not flips that less than or equal to a greater than, so that dissolves those parentheses. This part way over here to the right, I'm just rewriting. And now I am allowed to use the law of commutativity, which is probably over here somewhere in these identities where you can move something around like you learned in normal math. And if it's not, it is in a full book on Boolean algebra if you ever signed one out from the library. In other words, you can switch these two things because it's all being ANDed. This would be a good step by a professor of Boolean algebra. And then these two go together to just make num greater than 0, because when you have an A ANDed with an A, it all overall reduces to A, just like an A ORed with an A up there reduced. Right here's that identity that I'm applying right now to get that. Now you still have the and temperature greater than 0 over here, and that's as far as you can go with this problem. So to rewrite it so that people can see the answer, it's num greater than 0 ANDed with temp greater than 0. That's really the final answer there, and maybe you should circle your final answers on this worksheet, like up here and up here. Number 5, going quickly because it's the bell's about to ring in a few minutes here in this live class where I'm recording. I don't have a lot of room, but I'll squeeze it in here. Number 5. This is one of those ones where I'm going to change it to A's and B's. So we'll just say that A is this temp less than or equal to 0, which I see repeats here, here, and here. And we'll make num greater than 0 the variable B, and plug it in. And now let's just copy through our ors and our ands and our parentheses. This is a good trick for some of you that need this simplification. So there, I just kind of rewrote the problem with A's and B's. And now I just use these identities and good old-fashioned thinking to try to argue that my client on the trial is innocent. I am defending this person with just logic and rules. Like, how could he have killed somebody if he wasn't even in that state on that given night? Huh? That's how I would argue the innocence of somebody if they weren't even in that state. Well, anyway, what can I argue here? Well, here, this is just a really, really hard one. You might have to stare at these identities a long time. Oh, I'm sorry. Right there are the identities. Please look at them and get back to me on what you think is the one that applies. Camera, this guy, Patty something, I don't want to say last names on the internet, but Patty, he just told me what to do here. He said, well, you can switch the A and B here in this mini set of parentheses. And he's exactly right. The OR is commutative. And because the AND always applies before ORs, I'll keep that in mind anyway. Because AND is executed before OR in the order of operations, this AND is going to execute before that. So let's introduce a new artificial set of parentheses here and here. And let's realize that when you have something ANDed with that same thing ORed with something else, according to this identity right here, all of that simplifies to the thing that's listed twice. A and A or B equals A. Well, similarly, B ANDed with B or A, and I really should have not have rewritten this the other way around because that's misleading, even though it's accurate. All of this simplifies to just B. And we rewrite everything else. And anytime you have, well, this is commutative, so you can switch this A and this ORed with this B. And anytime you have an A ORed in A, it's the same thing as A. And you're still left with this B, and I need more room. So the final answer over here is A or B. Now again, I'm going to write the wrong answer. A in this problem was temp less than or equal to 0. And I'm going to put an AND in here, even though it should be an OR, for the people that don't listen to the whole thing. And over here we have num greater than 0. I'm going to make that blue so that I remember that that really should be an OR. So that really should be an OR, like we see the problem there. It's A or B. I changed it to this. I'm going to circle that, but it's really wrong. Okay, number 6, this is pretty easy. You just plug and chug. I like to say this is another way to do these problems if you don't like Boolean algebra. When you have a OR, it's like a plus, so 0 plus 0. This is a 2, but you really think of it as a 1, so you just added these two for an OR. And now you take these numbers, and you take A, multiplied it. So 0 times 0 is 0, 0 times 1 is 0, 1 times 1 is 1, and this 1 times that 1 is 1. Saying before the pause, the last row here in this truth table would be applying the B or A and, as you see, A or B. So it looks like we just have a B, this B column, being added to the A being multiplied with the previous column right here. So let's do an example. B is 0. Oh, we have to do multiplication first. A is 0. A 0 times A or B, that's 0 times 0, which simplifies to 0, and we have B ORed with that. B is also 0, so reduces to 0 plus 0. So therefore, all of that is simply 0. Let's do one more. Let's plug the zeros and ones in here, and we have A or B, which is this 1. We're multiplying that with a 1 plus an A, which is 0. Following the order of operations, we have to do this multiplication first. So 0 times 1 is 0, and this 1 plus that 0 is 1. So the final answer there to that second spot is a 1. The goal is to see if this column here is equivalent to this column here in terms of the zeros and ones. So far, so good. The 0, 0, the 1, 1, and I'll leave it to you as an exercise to figure out if this and this end up being 1 and 1. One more second. So there you have it. The answers on this worksheet are right there. And I'm scrolling up to show you all the answers on this worksheet if you made it this far in the video. One more time. There are the answers on the worksheet, circled like they should be on your worksheet. And number 5, of course, was over here. And number 6, I'm just leaving you finish it out.